All right, people, I'm back. It's time for another exciting volume lesson today. I know you're excited. I'm excited. You know, it is, getting to be the third day. We've done this in a row now, so, everybody's fired up about it, I'm sure. So today we're going to talk about how to find the volume of pyramids, which of course are these little jokers right here. And remember, if you've got any questions, comments, concerns, anything that you just really feel like you need to reach out and touch me about, there's my email address, dreid@davison.k12.nc.us. So, send it to me if you need to send it. So we're going to talk about today, this of course is a cube, and this of course is a pyramid. So I hate y'all are not here, and we can't do this live and in person today because this is one of my favorite little experiments that I like to do. But we're going to do a little water pouring experiment, okay, in just a little bit. But just for a minute, I want you to look and think about, okay, these have a relationship. The cube and the square pyramid, they have a relationship. And I'm going to try to do a little water pouring experiment and help you see and understand how that works. But we're going to start by going back and reviewing how to get the volume of a cube, which of course what we did a couple lessons back. All right. So our review lesson here to start out with is the volume of a cube. And of course, if you'll remember that is side times side times side, or otherwise known as side to the third power, or side cubed, which of course is where the term cubed comes from, because side to the third power is coming from getting the volume of a cube, therefore that's where they get the term cubed from. So if we had that, I think I can draw it over here if I scoop my paper over a little bit. So let's say we had this little cube. Dot that stuff in, just kind of make it look halfway decent at least. All right, so if we knew that was 6 centimeters, then of course that would be 6. Oh, it's terrible, I shouldn't have done that. But anyway, that would be 6 to the third power. And if we got our volume of that, side times side times side, 6 to the third power would be, what we got there? 216, okay, 216 centimeters cubed. Of course, if you don't have the exponent button, you just have to do those multiplied together, and it gives you 216. Get that off the calculator. Okay. Now, my question to you is, okay, if I know the volume of that, and this has some kind of relationship to it, just let me start out by saying if I take the bottom of this cube off and the bottom of this pyramid off, you can see, that they have the same base area, okay? It is a square, people. That right there, that is a square. Square. Alright, so you can see that they have the same base area. So of course you do side times side to get the base area. Alright, so that's going to come back into play in a minute. So my question is, so if I lay them this way, how many times do you think I got to pour and fill this up with water? Okay, and how many times could I pour it over into that? So ponder this question. Do you think if I fill this up with one time, fill this up with water one time and pour it into here, that's going to fill it up? Or if I fill it up with water twice and pour it over into there, do you think it's going to fill it up? Or is it going to be 3 or 4 or 5 or how many times you think it is? So that's going to be the underlying question, okay? How many times will it take for the pyramid to fill the cube? Okay. Got your answer? 1, 2, 3, 4, 5, 6, 10. How many times do you think it's going to take? Are you ready? Here comes the answer. All right. So I'm probably going to make a mess, so I'm not going to mess that paper up. I'm going to move this over here for a second. So, all right. There's the empty cube, right? No water in it. Empty pyramid. No water in it. All right. I'm using my favorite Coke product, okay, nice purified Dasani water. I'm going to drink a little bit of it right now to get started. All this talking today has got me parched. Alright, so I'm going to fill her up one time. Here we go. Let's hope the old man don't make a big mess. Alright, so there's one. In she goes. Alright, can you see that okay? Alright, so that's one. More water, not quite full enough. Kind of froze on there, so there's two. And you see. Alright. Here we go, sports fans. And here is three. Woo! And hey, would you looky there? That is full to the brim, people. That's full to the brim all the way up to the top. I don't think I can get another drop in there without it spilling over. That might be the best I've ever done it in my life. Alright, so it took me 3 times of filling the pyramid up with water, okay, and pouring it over here into the cube. Oh, see, I touched it and it came out. So there you go. Good thing I got my trusty paper towels here beside of me. Of course, I could have used toilet paper, but they're sold out of that. You'll get that joke later. Okay. So now, I'm just going to take that off and we'll clean up the mess. Alright, so you can see that it took 3 of these to fill up the cube. Alright, pour the water up now. So there's a relationship here between these things, okay? If it takes 3 of these to fill that up, and they have the same base area, we can write a formula for that. So as a fraction, how big is this compared to this? If it takes 3 of these to fill that up. You got your fraction? Anybody know? I can't hear you. Say it a little louder. Oh, yep, that's right. It's a third. A third is the number. So let's come back over here and write down a little bit of stuff here about it, okay? So let's go back and answer our question. How many times did it take for the pyramid to fill up the cube? That was 3 times. So here's what we're going to write for number 3. The pyramid is, and what was that fraction y'all told me? Oh yeah, 1/3. 1/3 of the volume of the cube. Okay, so that holds for all pyramids. Okay, 1/3 the volume. So the basic volume formula is going to be the same old thing we've been doing. Okay, so that would be side times side times side, and then we're going to divide it by what? That's right, 3. Or you can write it this way: s to the 3rd power divided by 3. Now that's for one that's, you know, got a square base. Okay, if it has a rectangular base, then you know it's pretty much the same thing, but you would do length times width times height and divide it by 3. So this one's with the square base. This one's with a rectangular base. In either case, you're going to divide by 3, okay? Because the pyramid is 1/3 of the actual volume, okay? So if it's a square, you're going to do side times side times side divided by 3, or s to the 3rd power divided by 3. If it's got a rectangle base, length times width times height divided by 3. So I'm just going to do one example because they're pretty much all the same, okay? So I'll do the rectangular one. So I always start out by drawing a triangle, and then we'll come back this way. You can think about the Great Pyramids out in Egypt if you want to try it into social studies, okay? Think about all the pharaohs that are buried out in these things, or well, I guess they still are. I guess most of the ones we found up to this point, they've already been cleaned out. But you know, once upon a time, pharaohs were buried in there. I guess they're empty now. So we've got our pyramid here. So let's say we knew this side was 70 kilometers long, and this side was 85 kilometers long. Now they're going to give you a little drop down and kind of height thing in here, okay, just like they would. Okay, so there's going to be some kind of arrow or something pointing here, and let's say it's 100 kilometers tall. All right. So on a normal rectangular prism, okay, we would do length times width times height. Okay, find the area of the base. Remember, that's base area times height. This, of course, is a pyramid. Okay, so it's, it doesn't have the complete sides going up. So then once you do that, you're going to take and divide it by 3. So length, width, height. So if you want me to, I'll put a little, that's length, width, height. So 85 times 70 is going to give me the area of the base, which of course is that rectangle down there. 85 times 70. Go multiply it by the height of the whole thing, which is 100. So after you do your
length times width, get the area of the base, multiply it by the height. Don't forget you got to divide it by 3. So let's pull out our trusty calculator here. So 85 times 70 gives us the base area, which of course that would be 5,000. I'm just going to write it underneath there. 5,950 times 100. All right, so that ends up giving us 595,000. If it was a rectangular prism, you'd leave it just like that. However, this is a pyramid, so we got to divide that by 3. And when you divide that by 3, it chops it down to 198,333.33, and it's still going to be, in this case, kilometers to the 3rd power, or cubic kilometers. Okay, I'm going to slide it up. So length times width times height divided by 3. Okay, that gives you the volume of a pyramid. And that's all there is to it, folks, just that extra little step there. Okay, so on the pyramid, remember, if it's got a square base, side times side times side divided by 3. If it's a rectangular base, length times width times height divided by 3. That part divided by 3 is the key to the whole thing for pyramids. I hope everything's coming across okay. Hope you can hear me okay. And if you don't, if you got problems or questions, don't forget to email me. Take pictures of your work. Make sure you show me what you're doing. And I hope you're being successful. Don't worry, people, that we're going to get through this together. Coming up, we got one more normal lesson where we're going to do some stuff on how to do stuff with word problems, just so you can make sure you do that. And then we're going to have a few quizzes coming up. So good luck.